Hi, so today we're going to be solving a question for SL Math over here, okay? And it's going to be relating to the topic of calculus, okay? Calculus and mostly integration over here, okay? Now, in this case, you're given a function f prime of x. So the function f of f prime of x is given as 12. So the function f prime of x over here is given as 12 minus 4x divided by 12x minus 2x squared. And if you simplify this, you can take 2 as the common factor. So this is 2 times 6 minus 2x divided by 2 multiplied by 6x minus x squared. Okay, so this is the function that you have been given, and you can cancel the 2's out. Now, we know that the function has a maximum point at P, and we know that the y-coordinate at P is ln of 27, so they want us to find the x-coordinate at P, okay? So for this one, you would have to know that, let's say if you have a function over here, which is given by x and then f of x, and let's say if you get this parabolic type function, right? So over here, the main thing that you would have to know is that whenever you are at your turning points, whenever you get to a maxima or a minima point, then the gradient m is 0. So if this is our maxima point, then if you take the gradient, the instantaneous gradient at that point, you get 0. So the reason we know this is because differentiation is just taking gradients, right? So we take the instantaneous gradient at the maximum point, and to take the instantaneous gradient, you just draw a tangent, okay? So we draw a tangent over here, and as you can see, it's a flat line, and in this case, the gradient of a flat line is always 0, okay? So at a maxima point, the gradient must be 0, and as you can see over here, the function f prime of x is just a gradient function, right? So this derivative is sort of like a gradient function. What this means is that if you have a function f of x, then if you input a x value, you get a y value, right? That's how the f of x function works. But the differentiation function or f prime of x function, the way it works is that if you input an x value into this function, then you will get some derivative value of m. So this m will be the instantaneous, so this will be the instantaneous derivative at that point x. Okay. All right. So now we want to find. Now we know that the function has a maximum point at P, right? So we want to find that. So the way we go about it is that we simply just say that f prime of x is equal to 0. That's what happens at maxima. And so when we get to that point, we can say that we can look over here, and yeah. So we saw that f prime of x is 6 minus 2x times 6x minus x squared. Okay? So if f prime of x is 0, then this should be 0. And if you just do cross multiplication, you get that 6 minus 2x is equal to 0, which means that x is equal to 3. Okay? So the x coordinate is 3, and they already gave us the y coordinate, which is ln of 27. Okay? So that was part A. That was a quick part. And now we can go and move towards part B. Okay? So if you look at part B over here, you would have to say find f of x, right? So we know that we've been given the function f prime of x. Okay? So f prime of x is just dy by dx, right? And we have seen that if you take the integral of f prime of x dx, then you should simply just get f of x. Okay? So the way you can think about it is that f prime of x is just dy by dx, and then you just multiply this by dx, right? So this just becomes this sort of becomes the integral of dy. Okay? So if you think about it, this is 1 multiplied by dy by dx. So this cancels out. So this just becomes the integral of dy times 1. And we know that the integral of 1 times dy is just y. Okay? And you would have to add the constant over here. But in this case, let's just say the constant does not apply, then you simply just get f of x. Okay, so we have just shown that the integral of f prime of x dx times dx gives you just f of x, which is y, right? Now we already have, so in this case you can see that f of x is just going to be the integral over here of 6 minus 2x divided by 6x minus x squared dx. Okay, that's all that we're going to get, and we know that this function is valid for 0 less than x less than 6. Okay, now when you get to this function, then the way you can think about it is that you can say that in this case let y is equal to 6x minus x squared. Then you get to the point that dy by dx in this case is just 6 minus 2x. Okay, so if you carefully observe, then you can write this as a function of 1 by y, or before that let y is equal to 6x minus x squared. Then if you do dy by dx, you get this function. So this means that dy is equal to 6 minus 2x times dx. Okay, so if you get this integral of 6 minus 2x times dx divided by 6x minus x squared, then you just do the substitution. This is basically the integral of dy by y. Okay, that's what you get. Now we have learned that the integral of 1 divided by y dy is just ln of y plus c. Okay, so the integral of 1 by y dy is just going to be ln of y plus c over here, right? So therefore we simply make the substitution. So we already know that y is 6x minus x squared, so you're simply just substituting it. So this is ln of 6x minus x squared plus c. Okay, so that's the main thing that we looked at over here. So this is just going to be ln of 6x minus x squared plus c. Okay, now after this, what we have to do is that we have to attempt to find c, right? So we don't know what c is going to be, so we can focus on that, right? So therefore we found that the integral of 1 by y dy is ln of y plus c, and so this is ln of 6x minus x squared plus c. And a good exercise can be, if you want to verify that you got the correct answer, just take the derivative of this function. If you take the derivative of this function, you must once again get 6 minus 2x times 6x minus x squared. So we can do that. Basically, if you have a function ln of f of x, then we know that the derivative of this function d by dx of ln of f of x, right? That function in this case, so you've got d by dx of ln of f of x, right? Okay, so in this case, this function, if we look at it, this is just f prime of x by f of x. Okay, so if you have d by dx of ln of 6x minus x squared, right, then you're simply just going to apply the chain rule. Okay, so this is just going to be the derivative of 6x minus x squared, which is 6 minus 2x times 6x minus x squared. Okay, and the reason this works is because in this case d by dx of, let's say, ln of x, we know is already just 1 by x, right? But when you add f of x, then this is just going to be 1 divided by f of x multiplied by f prime of x, because you're going to be applying chain rule. Okay, so that's going to be the application of chain rule. Okay, Alright, so we know that our integration has come out to be correct, and now we just have to find the constant c, right? So in this case, if you're going to be finding the constant c over here, then the way you would go about it is that we have been given 2 points already, so we know that we know there's a point 3 comma ln of 27, which we saw in part A. So this is the maxima point, right? All right. So in this case, if you have this point 3 comma ln of 27, right? So this is a point over here. Then you just simply substitute it back. Okay. So we can see that if you substitute x as 3, then this is ln of 6 times 3 minus 3 squared plus c is equal to 27. And so this is just ln of 18 minus 9 plus c is equal to 27. And so this is just ln of 9 plus c is 27. Okay? Right? So that is that's the idea that we would get over here. Okay? Right. Oh yeah, sorry. So this y point is actually ln of 27, not 27. So this is ln of 27, ln of 27, and ln of 27. And then if you just do the subtraction, then c is just ln of 27 minus ln of 9. And we know that ln of a minus ln of b is just ln of a by b. So this means that c is just ln of 27 by 9, which just becomes ln of 3. Okay? So therefore, our function over here, which we started off, so y is the integral of f prime of x dx. So that's just f of x that we did. And that's just equal to ln of 6x minus x squared plus ln of 3. Okay? Now, the question asks us to show this as a single logarithm. So in this case, if it's a single logarithm, this is just ln of a plus ln of b, which is ln of a times b. So this just becomes ln of 3 times 6x minus x squared, and that's what f of x becomes. Okay? So that is your final answer. Okay? Now, after this for c, this one has to do with transformation of functions. So you're using a scale factor. So when we look at, so we can put question c over here, right? So the graph of f, so we already found what f of x is over here. So the graph is transformed by a vertical stretch. So this is the key word. You have a vertical stretch by a scale factor of 1 by ln 3. And so the image of P under this has coordinates. So this is coordinates, a comma b. So find the value of a comma b over here, right? So the main idea for this is, because it's a vertical stretch, let's say if I give you a function, right? So let's say if this function over here is sine of theta, and let's say if this is theta, then the sine of theta function looks like something like this, okay? So it goes from +1 till -1. So it oscillates in the +1 and -1 direction, right? Now, in this case, if I introduce a scaling factor, right? So if I'm going to introduce a scaling factor over here, then let's say if we have a scaling factor of 2, right? Okay, so when you get a scaling factor of 2, so let's say if this is 2 sine of theta, right? So I'm just applying a scaling factor, then this is how the sine of theta function is going to look like. Okay, so it will look something like this, right? So that's how it would look. So as you can see, the x values did not change, right? The x values did not change. Okay? So the only thing that changed is your y values over here. So your scaling factor is only going to affect, so if you have a comma b where a is the x value, and you scale it by 1 by ln 3, then you're only going to affect b, which is the y value, because it's a vertical stretch, and a is not going to be affected. So if you introduce a scaling factor on a comma b, if you introduce a scaling factor of 1 by ln 3, then the new function is just a comma b times 1 by ln 3. So you're just multiplying the y values by the scaling factor. And so if you look at the multiplication of that, then so if you look at the value, the maximum value, we found it to be 3 comma ln of 27. That was the thing. So this is just going to be 3. So a is going to be the same. And in this case, the original value of b, as we saw, was ln of 27. So now we're just going to do ln of 27 by ln of 3. Okay? Right? And the main idea for this is that these are going to be the two values given over here. Okay? Now, ln of 27, you can just write it, so you can write ln of 27 as, okay, so if you look at ln of 27 by ln of 3, so I'll just erase this over here. So if you look at over here, if you look at ln of 27 by ln of 3, then you can just write ln of 27 as ln of 9 times 3 divided by ln of 3. Okay? And so the main idea that you can, or actually you can write a ln of 27 as ln of 3 times 3 times 3, right? Because 3 cubed is 27. So this is ln of 3 cubed by ln of 3. And so the ln of 3 cubed is just 3 ln 3 by ln of 3. And then these two cancel out. So you're left with only 3. Okay? So if a is equal to 3, then b is also equal to 3 if you're introducing a scaling factor of 1 by ln 3. Okay? So with that, we're done with this question. And yeah, don't be scared of looking at, it took 2 pages. It's more of that I wrote it a bit big so you would be able to see clearly. Okay? And also because I was explaining, that's why I took more space. In this case, if you don't have to do the explanations, you can be done quickly.